In order to actually use it to analyze the effects of various forces and loadings and how the object is going to act under stress, it's a little bit of a convoluted process, but I'm going to show you the easiest way to get there. So to show you in this demo, I'm going to basically create a mailbox that we can analyze with various forces. So I'll make this the mailbox portion, and we will give this a cylindrical post. So we'll call this post. I just need to resize them. So let's, I don't know, let's give it like a 2-inch radius. And I want this maybe to be 4 feet high. So we'll take a look. So based on that, you've got my post. Unfortunately, the mailbox is very tiny. If I close that, you'll notice my mailbox is actually all the way down here. So what we'll do is let's make it, I don't know, maybe make it a big mailbox. So 2 feet long. We'll make it maybe 1 foot wide, and we'll make it 1 foot tall. All right, so we've got our mailbox here. We've got our post. We can use Spacebar to bring that back in. Now the only problem here is that these are not in the right locations. So I will move around to, let's say, the right side of this, and let's go ahead and we will move the mailbox up. So we go to placement, position. The z-axis is what I want to use to raise that up. So we'll kind of jump that up a little bit. Move that until we get, it's a little bit too high. So we're looking at somewhere around maybe, if the post is 2 feet high, let's make it 2 feet. Nope, I'm sorry, the post was 3 feet high. So we've got 3 feet, maybe 3.5. And I need to move it over on the y-axis here. So on the y-axis, we will just move this over until it's about center. That looks good. So we'll move this around a little bit. If I look at the front here, I probably want to move this back just slightly. So that would be the x-axis. So I will just adjust this, and there we go. So now we have a very crude mailbox. And if I want to analyze this, we're going to have to switch the window that we're in. So the first thing we need to do before we do anything is you can't analyze the object unless it is just one object. What I mean by that is this is a mailbox and a post right now. In order to fix that, what we're going to do is we're going to use either Command, hold down Command and click the individual parts, or if you have an entire list of parts, click on the first one, hold down Shift, and click on the last one. You can't click and drag, but either click and then Shift click, or click and then Control click, depending on the parts you want. But you need to get everything selected. And then you go, instead of where you used cutout before, you want to use the one next to it, which if you kind of mouse over says make a union or merge the shapes. So if I click that, in this case they're calling it Diffusion now, I now have one object, which is those two pieces combined together. So I'm going to rename this my mailbox because now I have one fused piece. So this entire thing is now just one object. It's no longer two objects. So once I've done that, we're going to go to what we call the FEM, which stands for like finite element mesh, I believe. But finite element analysis is kind of what the technological analysis that these types of programs complete is called. So I'm going to switch off of parts. I'm going to come here where I had the part menu. I'm going to go to FEM. And you get a ton of these crazy options. We're not going to look at all of them. I'm going to show you 2 or 3 of them that we're going to be using in this course. And that should be enough to get us through. So the very first thing we're going to do is we're going to click on this A right here because that's going to set up an analysis tab for us. That's where we're going to be able to put everything in that we want. So that's the very first thing. Start with analysis. The next thing would be to choose a material. So if we click on that, it gives us all sorts of information if we want to put in our own custom, but we're going to use this drop-down menu right here, which is kind of right here in the top. There's all different types of steel and glass, and on the bottom you have wood. I'm just going to randomly choose one that looks cool. I'm going to use steel E295-GC. It's just a type of steel. So if I click that and I choose OK, now underneath analysis I have the solid material. So now this whole thing is going to act as if it's steel. The next thing we're going to want to do is we're going to want to highlight our object, and we now need to use what's called a mesh. So we need to kind of break this down into smaller shapes, typically triangles, so that the program can analyze a bunch of basic geometric shapes as opposed to one large object such as this. So if I highlight my mailbox, or whatever your object is, and I come over here, I'm going to use what's called an N mesh. I'm going to click on End Mesh, and it's going to give me these options. Most of them don't really matter, but the fineness is going to give you better or worse results, but there's a trade-off. If I want very fine, I will probably get the most realistic results. But the shapes that they are going to use to analyze this will be so small, it might take anywhere from 15 to 30 minutes, depending on your computer, just to get this mesh created. So I'm just going to go with coarse for right now. I could always adjust it later. But if you use coarse or very coarse, it's going to give you your results quickly, but they might not be the most accurate. Whereas very fine will give you much better results, but could take significantly longer, depending on the computer processor and all that kind of stuff. I think coarse is okay for what we want to do. I'm going to click Apply. And if you wait a second, you will now notice that I have this mesh. It's kind of broken this down into a series of triangles, which it can now use geometry to analyze. So I'm going to hit OK. And I can zoom around the model like I typically could before, but now it has this mesh on it. But I need to tell this model or this mesh what to analyze. So right now it's got a mesh on it, which is nice, but there's no forces, there's no loading cases, there's nothing. So in order to do that, we're going to be using these two features. This little one here that has a lock and this one that has an arrow. Now the lock is called a constraint, meaning if this mailbox is obviously planted in the ground, there's one portion of it that's not going to move very much, and that would be that bottom section down here. So the top is, it's a rigid structure, so it's not going to move. But if I were to push at the top of this with my hand, it would probably move a little bit. But if I pushed at the bottom of this pole, it's not going to move at all because it's fixed in the ground. So we need to tell the program that that's the case. So if I click on this case here, if your model disappears, as mine did, you just click on this Model tab, and we need to use Spacebar to bring our model back. Okay, so it usually defaults away once you add the mesh. Spacebar will bring that back, and I can go back to this Tasks menu. Now what I need to do is I need to rotate this around, and I need to tell the software which part of this program is embedded in the ground, meaning which part is not able to move. That will be the bottom part. So as long as I've chosen this lock option here, it says select multiple faces and click add or remove. So I want to choose this surface here. Let's see if I can get it. Maybe I'll zoom in. Whoops. If I zoom in here, you just want to make sure you choose this face here. It's hard to tell, but it's kind of like selected in green. And I'm going to click Add. So that just added that face, and you'll notice it gives these 4 little kind of squares. It may be more or less based on what you've created. But those little red squares tell the program that this section cannot move. No matter what happens, this part is fixed to the ground. All right, everything else, since it's a mailbox, is probably kind of just out and above the ground. So that's the only point that I'm going to have to say is fixed in this case. So I'm done here. I'm going to hit OK. So I've now told the program which portion of this should not be allowed to move, which should be fixed in place. I now need to apply some kind of force, which I'm going to use with this red arrow. Same situation. It's going to ask me to choose some faces. We could try a few different things. Let's try the front. So if I click on the front, you're going to notice that those arrows are, if I zoom in, those arrows are pointing outward. I want to simulate what happens if maybe someone pushed on this mailbox on the face of it. So the load that I want, let's say, is going to be, I don't know, like 5,000 newtons. And I want to reverse the direction. So by reversing the direction, instead of something pulling on this thing, if you look at the arrows, now they're pushing. So what we're simulating here is a situation where this mailbox is being pushed on its face, and every part of it can move. It's going to resist because, remember, we put steel, but it's going to resist, but these portions can move. This portion down here is fixed in the ground. So once we've got this set up and we say, okay, I want to know what happens if this is stuck in the ground and someone pushes on this with 5,000 newtons, I'm going to hit OK. And then what I can do is I'm going to want to go to my analysis. Let's shut off the mailbox here. Bring my mesh back using Spacebar. So now I want to take this mesh and I want to apply these. And all you need to do is you need to come down to where it says Calculex Tools. As soon as you click on Calculex Tools, you'll notice this option right here appears, which is runs the calculations. It kind of looks like, I guess, like a little rod on a yellow paper. If I choose something else, you'll notice that it gets grayed out, so I need to choose Calculex Tools. Then I click on that and I simply wait. So that was pretty quick. Sometimes you get the the spinning wheel, but this has run, and I have my results down here, my Calculex static results. All I need to do, we'll move this so I can look at it from the side. All I need to do now is double click on these results, and it's going to give me whatever I'm looking at. So right now, if you put nothing and I zoom around, you'll notice that everything's green because I'm not looking at anything. But I am able to look at the displacement. Orange here means it displaces a lot, and green tells me it does not displace. That makes sense because this section is stuck in the ground, whereas this is free to move. If I want to adjust my slider where it says show, I can actually kind of see an over-exaggeration of what's going to be happening here if someone pushes on it. I can look at the stresses instead. It's not really important what all these different stresses mean just now, but you'll notice that as this thing gets pushed, there's not a lot of stress at the top, which is the mailbox, because the mailbox is free to move. But if you look down near the bottom, that's where most of our stresses are occurring because this is trying to bend and it's going to try and resist. So this will allow you to kind of figure out what the deflections will be like, what the stresses will be like, and this will help you kind of strengthen certain areas of any design you have based on these results. If I wanted to quickly change something, Spacebar will bring my model back. Let's say I didn't want to have the forces here. Let's say I wanted to have the forces maybe pushing down on top. So all I need to do, choose my constraint force. If I double click on it, let's remove this. So we are going to delete. Nope, that is not working. So if I add a reference on the, okay, this is not quite working. There we go. Control click will delete. So if I hold down control and click on those, I can delete them. And then what I'll do is I will add the top. So I want to add the top and yep, pushing down. So if it was flipped up, oops, why is this not working? There we go. If it was flipped up like that, I would have to unchoose reverse direction. But I want to choose that surface so that it is being pushed down on. Let's even make it like 10,000. Let's double it. And now, of course, this is a very glitchy program, so I'm going to reverse that force, okay? You might have to kind of double check things every now and then. So now let me delete my results. Control click will delete. And now that I have everything here, let me go ahead, Calculex Tools. Let me run this new analysis based on those forces. All right, and now what we can do is we can do the same thing. I'll come down here and look at my results. If I look at the displacement, you'll notice the displacement is a little bit different now because it's being loaded from the top. If I want to look at my stresses, same thing. In this case, there's actually much more stress on the pole, at least along the entire length of it, because this is actually being pushed down on. All right, so this will give you the ability to kind of analyze your objects, determine things like the stress, determine the displacement of it. You can kind of see an exaggerated view, so you have an idea of how it's going to deform. And it's pretty powerful anytime